In this video, we're going to continue looking at how we go about implementing this linked list data structure in C++. So in one of my previous videos, we looked at creating this node class. So in our case, we were trying to create a node to be representative of a contact that you may find in an address book. So we kept it very simple and only had a name, but we also had this next pointer. And we have to have this next pointer in order for us to have a node associated with a linked list, because this next pointer is a pointer that actually refers to a node of the same type. So refer to or point to the successor node, or the node that would come next in a linked list. But the thing about the node class, while it allowed us to create as many of these nodes as we wanted to, it didn't allow us to actually link them together. We didn't have any operations to associate these with a particular linked list. We could just simply instantiate or create as many nodes as we wanted to. So in order to be able to link these nodes up, what we're going to do is create a new class called our list class, and it will have operations in there to allow us to maybe add nodes to the head of our list, to the tail of our list, somewhere in the middle. It's really up to us. So one of the key things that we have to have is this head pointer. So this head pointer is going to be a data member associated with the list class, and it's going to be of the appropriate type. So in our case, it would need to be a contact pointer. So initially this head pointer will be set to null, so it won't point to anything, and that just indicates that we have an empty list. But we can add things in. So you can imagine adding in new nodes and just having, for the first case, having our head pointer point to that particular node. And we could add nodes in afterwards, or we could put in, a new node at the head. It's really up to us. The way I have it depicted here is we just have nodes being added in subsequently behind each node. So let's go over there to Eclipse and go and implement this linked list class. Okay, so I've loaded up Eclipse now, and I've also opened up our contact list project. So in one of my previous videos, whenever we created the node class, we created this contact.h file and contact.cpp file. And now we're going to be creating this list h file and list cpp file, and also a little application to just test out our code. So what we'll do is just simply create a new header file. So we'll just right click here and go to new and select new header file, and we'll call this particular file contact list.h, and go ahead and click on finish. So the first thing that we'll do is just do a pound include for our contact.h file. Without having that contact.h file, we will not be able to create nodes. So once we have that, we can create a class, and we'll call the class contact list. You could call it anything. You call it linked list, list, whatever it may be. But since we're creating a contact list, that's probably an appropriate name. So we'll go ahead and create a public section here. And in the public section, we'll have our prototype for our constructor. So we'll have contact list. And our constructor is not going to have anything passed to it, so we'll have an empty formal parameter list there. So that's our prototype for the constructor. And the only other thing that we'll have in our public section is just a member function to be able to add a node to the head of our list. So we're going to keep things very simple in this video and not have a whole lot of operations going on. Later on we'll come back and maybe expand on the operations associated with this contact list. But for right now, we'll just have this void returning function that allows us to add to the head of the list. So we have a couple of choices here in terms of what we could do for the formal parameter. I think what we'll do is just pass in a string, and then we can use that string as the name for our contact and construct a new contact and then add that contact to the head of our list. So we'll pass that string in by constant reference. So we'll have const std : string, and then ampersand here to indicate it's being passed in by reference. And the reason why we're passing it in by constant reference is because we have no intentions to change the name there associated with the contact. So we have that, and now we'll create a private section here. And in the private section, we'll have to have that head pointer. So the head pointer is going to be of the appropriate type. In this case, we're creating contact nodes, so it will be a contact pointer, and it will just be called head. And the other thing we'll have is maybe the size associated with our linked list. So I'll have an int variable here called size. So that's it for our contact list.h file. So let me go ahead and save that particular file, and now we can go and create our contact list.cpp file. Okay, so we'll go back over here to our contact list project, right click, go to new, and then select source file, and the name of the source file is just going to be contact list.cpp, and then click on finish. So now we can start writing our constructor and our other member functions associated with our contact list. So the first thing we need to do is a pound include for our header file. So we'll do contact list.h here at the very beginning. And the other thing that we'll do is a using namespace standard. That's perfectly fine to do inside of a CPP file. And now we'll write our constructor. So the constructor will just simply be contact list, and then use our scope operator, and then we'll have, let me save this so it'll actually have our drop down list there for auto completion. So contact list colon colon, and now you see the drop down list for auto completion, so we can select that particular constructor there. And now what we'll do is it initialize our list, and what we need to initialize is our head to having the value of null. And you really have two choices for specifying null. So null is just a macro, so you could use capital N-U-L-L, all those caps, or you could use the value of 0. I think I'm going to use 0, even though in maybe some of my previous videos I used null. It's really up to you, and it's kind of a preference in terms of which one you use. So we'll have that. So head is set to null, and then we'll also have size set to 0. And that's going to be it. So the body here can be empty. We don't have to put anything in the body since we've initialized both the head and also the size. So initially we don't have any nodes associated with our list. Now the next thing that we're going to do is create this add to head function. So this add to head function is going to require us to manipulate some pointers. And I think what we'll do is go and draw a logical representation and see how the pointer should be adjusted if we're dealing with an empty linked list, or if we already have a node being pointed to by our head pointer. So let's go draw some pictures, and that way I'll make it very clear in terms of what code we need to write for our add to head function. So whenever we call this add to head function and pass in a name, what will happen is we'll construct a brand new contact node, and we'll have a certain name. So we'll say that maybe the name that was passed in was Bob, and we'll also have our next pointer associated with this node. So the next pointer, if we go back and look at our node class, we'll know that that's initialized to the value of null. And we'll also have a pointer that's capable of referencing this node. So this node gets created out there on the heap, and we'll say that the name of that pointer is maybe new one to indicate that this is a new node that we're wanting to add in. So we'll have this pointer here referencing Bob. So this simply holds the address of this particular node out there on the heap. And now we get to the point where we have to make some decisions. So we could be in the situation where our head pointer is pointing to null. So this is indicating that we have an empty linked list. And if that's the case, the situation is really easy. We just simply need to assign the address here, which is held by new one, to head. So we're just taking this value here and assigning it to head. So head's a pointer that points to contact nodes. New one's a pointer of type contact, or contact node pointer. This simply holding the address here of this Bob node. So we'll just update that to indicate that this thing here, this address, has now been assigned to head. So we'll just erase this business here, and now we'll update this so that head is now pointing here to the new one. Now whenever this add to head function terminates, what will happen is this new one here was a local variable. So that local variable new one will lose its scope and also lose its life there in memory or on the stack, and will be removed. So we'll no longer have this new one here associated with that Bob node. So that gets removed as soon as we terminate that function. And so the next time that we call this add to head function, we'll create a new contact node. So I'll represent that here. And we'll say that this particular contact node had the name of Sally passed in. So we have Sally here for the name, but we still have our next pointer. And the next pointer will be initialized to null. So I'll represent that here. And this will just simply be our new one pointer. So we'll have that local variable created and now points to this new node that we just created. And what we need to do, since this function is called add to head, is make sure that this particular node here that we just created is added to the head of our list. So what do we need to change? Well, one thing that we can do is we can take new ones next and set it to be equal to whatever head is pointing to, since head is pointing to the current head of our linked list. So that would really be the first thing that we'd do, is set new ones next to be pointing to whatever head is currently pointing to. So we'll go ahead and make that change. So we'll just simply change this here to point to the same thing that head is pointing to. So we have two pointers there going to the Bob node. And now check this out. We can take head and set it to new one. So if we take head and point it to the same thing that new one's pointing to, then we end up with this picture. So we'll update that. So now we have head pointing to the same thing that new one's pointing to. So now we have Sally at the head of the list, and whenever that function terminates, that add to head function terminates, we'll remove new one again. So that'll be removed from the stack. So I'll go ahead and indicate that that gets removed, just to draw the completed picture whenever our function terminates after adding Sally in. So that's basically our linked list and how we go about adding to the head of a list. So let's go back over to Eclipse and implement this code. So this add to head is a void returning function, and it belongs to our contact list class. So we can make use of the scope operator there, select our function, and we'll be passing in a string for the name by constant reference. So I'll just provide the formal parameter name there for name. And then the very first thing that we got to do is actually create our node. So we have to have a pointer that's able to reference that node because we're going to be creating it out there on the heap. So we'll have a contact pointer, and we'll call it new one, just like what we did before. And we'll say that we got to create it out on the heap, so we got to use the keyword new. It's a contact node that we're creating, and we've got to pass in the name there to the constructor. So now we need to test to see if our head is equal to null, to test to see if we have an empty list. So we got to test to see if head is equal to null, and I'll just use 0 here. And if that's the case, we just simply need to set the head pointer to now point to whatever new one's pointing to. So they both are pointing to the same thing. And then the else part there is the second thing that we worked on, and that was the case where we had to set new one's next. So new one's next had to be set to head, and then once we did that, we had to set head equal to new one. Hopefully it's clear that we shouldn't do the head assigned to new one before we do the new one's next assigned to head, because if we assign head to new one, then we don't have a pointer. Let me flip back over there to what we had drawn our logical representation, and maybe I can do a Control Z to get us back to this situation here. So if we tried to take our head pointer here and set it to new one before we set new one's next, we'd end up in this situation here. So I'm going to set head here, take head's pointer, and now set it to new one. And now we don't have any ability to get to this node here. So if we try to set new one's next to something, it's like, well, what do we set it to? Well, Bob is not being referenced by anything. Bob actually becomes garbage out there because we don't have a pointer able to get to Bob. And that's not really good news there. So that's the situation of why the ordering of that is the way it is. So we set new one's next here to head, and then head to new one. And that pretty much wraps up our add to head. The last thing that we need to do is just increment our size. So let's increment size there by 1. And that's it. That's the only thing that we're going to do for now, at least, inside of our contact list.cpp file. So what we'll do now is write an application file and test out our code. Actually, there is one thing that we need to do before we go and create our application file. And if you notice here, we have this next pointer here, and this next pointer is actually a private data member of our contact class. So in order to be able to access that, what we're going to do is go over here to our contact.h file and make our contact list a friend class. And so that's going to allow us to access those private data members. So we'll say friend here, class, and then specify what class we're making a friend. Contact list. So contact list will be able to access all the private data members. So now that we have that added in, let's go ahead and save these files and build them, and hopefully the only error that we would get now is that we don't have a main. So let's go ahead and build this, and we can see how it works. Yeah, and it looks like the only error that we're getting here is that we don't have a main. So let's go ahead and create an application that has a main. So go over here to our project, go new, and then source. And the name of our application is going to just be contact list app.cpp, and click on finish. Okay, so in this file here, the first thing that we need to do is do a pound include for our contact list.h file. Otherwise, we'll not be able to create our linked lists. We'll also do our using namespace standard. And now once we have that, we can create our main, which is what the linker was looking for before. And now we'll just, I guess we'll create a linked list for testing. So we'll just create our linked list out on the heap. So we'll have a contact list pointer here, and we'll call it maybe CL1, and we'll create that contact list, or at least the empty contact list, out on the heap. So we'll have that. What we'll do now is set up a looping structure, and this looping structure will just simply ask the user to input a name, and if they input a particular name, then we'll go about adding that particular name to the head of our list, and we'll let them know that they can input Q, so maybe a lowercase q, to terminate the program. So in order to store a name, we'll create a string variable called name, and then we'll have our while loop, and this is going to be a while true loop, and it's going to be what we call a loop and a half. I don't know if I've discussed this in a previous video, but basically what we're accomplishing with this loop and a half is preventing redundant code. So typically what you would have without the loop and a half is you would ask the user to input something outside the looping structure, and then you would test a particular condition there in the while loop. But the problem is you're going to have to ask that same sort of question that was asked outside the while loop back inside the while loop if they've inputted some valid data. So we're preventing that with this loop and a half, and I'll show you how it works. So we're going to have a cout here, and what we're going to output to the user is for them to enter the name of the contact, so whatever contact that they're wanting to add, or Q to quit. So those are the two options that the user will have. And then what we'll do is just read that in. So whatever they inputted, we'll read that into our name variable. And then once we have the name, we can test to see if that name is equal to Q, and if that's the case, that's our sentinel value to actually quit. So we'll just have a break statement here, so that'll break us out of this while loop structure. So it's not the case that we'll continue looping forever. And then if that's not the case, then we could get to this line of code where we'll just simply call our add to head function. So we'll do add to head, or I can just select it here from our drop down list since that's a member function. So we have the autocomplete going on, and then we can just specify name there as the parameter. So let me go ahead and save this and build it to see if it actually builds. Hopefully it builds okay. Yep, looks like everything's building okay. The only other thing that I need to discuss is the fact that we don't have any sort of print statements involved here, but we could use the debugger to see what's going on. So let me just, now that we have this compiled correctly, let me go ahead and launch the debugger, and this will be the last thing that we do, and we'll probably pick up here in the next video. So here inside the debugger, what we can do is start stepping over our code, and this is the step over button, or you could also press the F6 key, which is mapped up to step over. So we're going to step over and get inside of our main, and you can see that here we've already allocated space on the stack here for our contact list pointer, but we haven't actually created our contact list. That will not occur until we step over this line of code here, but as soon as we do that, you'll see that a value has now been assigned here, and that's the value associated with our contact list out there on the heap. Let me go ahead and resize this a little bit just so those things are closer together. And now we'll step over again, create our name variable, and now we're inside the while loop. So inside the while loop, we'll do a couple of step overs where it's going to be asking us for input, and we'll say that Bob is the name of the contact that we're going to create, and we'll hit enter. And now I'll test to see if we typed in Q for quit. We didn't, and now we get to the add to head function. So let me go ahead and step into that function, which is the F5 key, and we're about to create a new contact node. So what you can see here is that we have this here, and this is referring to our contact list that we've created, CL1, and currently the head is set to null, and also the size is 0. So we verified that, and we're about to create a new one here. So we have the new one variable, and the new one variable just holds some junk value right now, and if we do a step over operation, it will then be assigned to the address for that node, that contact node that we just created. So it's going to test to see if head is equal to null, which we can verify that over here in our variable list, that head is in fact equal to null. And if we do a step over, what we're going to do now is set new one here. So this address here is going to be set to head, and we can verify that that actually happens. So we see that 6D1A10 is in fact what's assigned here to head. And we'll also increment the size, and then we'll return back to our main where we have our while loop. We'll step back into it one more time, get another name. So this time we'll type in Sally just to follow our example. And now that we have Sally, We'll do a step over operation and step back into the add to head, and this time we can see that the head is no longer set to null. We'll go ahead and create our new node, which is at 6D1A90. Fail this condition here, so that's not true, and so we get into the else part, and the first thing that we're going to do is take whatever values in head and set it to new ones next. So if we expand the listing here, we can see new ones next is set to null, which is what we'd expect, and what we're going to do is take this value here and set it to this value for next. So we should have this 6D1A10 set here. So we'll do a step over, and we can see that that does in fact occur. And now we're going to take new one, which is the 6D1A90, and set it to head. So it'll now be set to that. And we can see that that does in fact occur. And then we'll increment our size, and we'll do another step over. And this time I'm going to enter the value of Q for quit. And we can see that our program, I'm going to just go ahead and run this. And so it terminates. So in our next video, we'll pick up here and maybe examine some more stuff going on with the debugger, but certainly add in some code so that we can actually traverse over our linked list and print it out. And so that's it for this video.